Kia ora, Year 9. This is a new video to go with some of the practice tasks we've given out for the linear equations topic. So this goes with questions 27 through to 33. These equations start off at developing level, but they quickly move up to proficient and onto advanced. Most of them have got at least 3 or 4 steps, and a lot of the answers are quite yucky numbers. There's one question in here that I just want us to delete, and it's this one here, question 32. That one is an accident. It's a quadratic with no real solution, so we'll get to that in a year or two. But for now, I'm going to go through the other ones reasonably quickly because I've done slower videos on all of these topics. Okay, so let's start with question 27. We've got x over 6 minus 2 equals 8. So the first step is to add 2 to both sides. We get x over 6 equals 10. Next, we multiply both sides by 6. X is equal to 6 tens, which gives us 60. Okay, so that's the solution to the first one. Let's have a look at question 28. Right, so this one is different because you can see that it's got the x is in the denominator of the fraction. So we have to be careful when we're dealing with that, but we use the same rules as before, that we can always do the same operation to both sides of the equation. So here I'm going to multiply both sides through by 5x. That will give me 2 is equal to 12 times 5x, which is 60x. Now we're back to a one-step equation. We divide both sides by 60. So we have 2 over 60 is equal to x. But we have to simplify that fraction. So we're looking for the highest common factor in the numerator and the denominator, and that's 2. So my final answer is x is equal to 1 over 30. So that's question 28. Right, question 29 is one where we've got just one more little step of working. I'll just clean that up. So if we take a look here, we've got 5 minus 6x equals 8. Again, we've got x in the denominator. The first step is to collect up the constants together, the numbers, and we'll do that by subtracting 5 from both sides. Right, so I've taken away 5 on this side, and I've taken away 5 on this side. You don't need to show those loops, but I know that some of you find doing that a useful way to check what you've been doing. Next, I'm going to multiply through on both sides by x, and we get negative 6 is equal to 3x. We're back to a straightforward one step. Divide both sides by 3, and we get negative 6 over 3 equals x. But again, we must simplify that. That gives us x is equal to negative 2. So that's question 29. The next one is similar with just one little step up in it. So instead of having 5 divided by x, we've got 5 divided by x plus 1 plus 8. And if you're watching this and you're in my class, you'll know that I recommend that you always put the brackets in, make them really obvious, because brackets are implied whenever I'm working with this divide sign. So in here, first of all, I'm going to clean up my constants, my numbers. I'm going to combine those and get 73 is equal to 5 divided by x plus 1. I'm going to multiply both sides by x plus 1. That gives me 73 times x plus 1. That's equal to 5. And now I've got 73x plus 73 is equal to 5. 73x is equal to negative 68. And now x is equal to negative 68 divided by 73. Now I can quickly check that there are no common factors in there. But there aren't, so let's just quickly look at how I can do that really fast. Well, I know that 2 is not a common factor in here. 3 is not a factor of either of those numbers. Remember, I can see that quickly because I know that 66 and 69 are both multiples of 3. 4 won't be a factor, 5 is not a factor, 6 won't be a factor. We should check 7. 7 doesn't go into 68 or 73. 9 won't go in either. So you're probably wondering how I'm doing that so quickly. Let's just quickly go through that because I think I've got time in this video. So think about the factors that we could have in here. Let's look. Well, 2, because 2 doesn't go into 73, that means that a common factor won't be 2, but it also won't be 4, 6, or 8. In the same way, 3 isn't a factor, so 9 also won't be a factor. 5 is very easy to check, and 5's not a factor. And we have to manually check 7, and 7's not a factor. Okay, and I don't have to go any further than that because I'd be getting up to the going backwards part of the factors. For example, we know that 68, what's the closest thing we've got in there? Well, 7 9s is 63. And so we can check through here and here, but we don't need to keep going up past 9. Right, I'm getting sidetracked. I'll get back to our equation solving. Sorry about that. If you were watching and you didn't need the little divisibility reminder, hopefully you skipped that part of the video. Okay, so I've got a couple more questions. Let's just go back to the start and see where we're at. Where are they? Somewhere here. We've got our questions. Here they come. Right, so we're on to 31 and then 33. And in both of these, again, we've got x in the denominator. So 31 goes like this. 1/2 minus 2 over 3x is equal to 8. Well, again, I want to combine my constants. I'm going to do that quite slowly here. I've got negative 2 over 3x. Negative 2 over 3x. And 8 minus 1/2 we can think of as just 7.5. Now, we never ever work with mixed numbers when we're working with algebraic fractions, so we convert that into 15 over 2. So negative 2 over 3x is equal to 15 over 2. Some of you will be able to do this quickly, but I'm going to go quite slowly. I'm going to multiply both sides by 3 over x. That will give me negative 2 is equal to 45x on 2. Now we get negative 4 is equal to 45x. And the last step in here will give me negative 4 over 45 is equal to x. And there are no common factors, so we're done with that one. Now, as I said, we're going to ignore question 32. Question 33 is this one here. 4 over 5x plus 4 is equal to 3 over 2x. Whoops. 3 over 2x plus 1. So let's put in our brackets. And I know, again, that some of you have learnt to do this thing that you call cross-multiplying. Now, that's really cool as long as you understand why it's working. So I'm going to do this question, first of all, really slowly, showing you the common denominator and the build-up, and then I'm going to do it faster, which is how you do it if you've been doing these for a while. So the first thing to remember is that if we're working with fractions, it's useful to have equivalent fractions. To use equivalent fractions to have a common denominator. So my common denominator in here would be this times this. Right, that's going to be the lowest common multiple of those two denominators. So what did I do to the 4? What did I do to the 5x plus 4 here that I have to do to the 4? Well, I times in 2x plus 1. So here we're going to have 4 times 2x plus 1. And over on this side, the 2x plus 1 got multiplied by 5x plus 4. So we have to do the same thing to the 3, multiply it by 5x plus 4. Now what I'm going to do is I'm going to say that I'm going to multiply both sides by this. Right, now I don't usually bother writing out that step, but that's what we're doing when we go to writing down this next line of working, which is to say that we've just got the denominators being equal to each other. As I said, I'm doing this one really slowly, and I'm going to show you how to do it quickly shortly. So now we expand. We've got 8x plus 4 is equal to 15x plus 12. Working as we usually do with x on both sides, I'm going to subtract the 8x from both sides, giving me 4 equals 7x plus 12. Negative 8 equals 7x. And lastly, we get x is negative 8 divided by 7. Right, so that's going the slow way. I'm going to show you how we'd solve that problem once we'd be doing these for quite a while. Well, I'm going to multiply both sides by 5x plus 4. That gives me 4 equals 3 times 5x plus 4 over 2x plus 1. And now I'm going to multiply both sides by 2x plus 1. This is still not the fastest possible way, right? This is putting in one little step. Okay, and now I would expand and I'd get what I got before. I'll just put that line in there and then we'd work through from there. So that's kind of the intermediate steps method. And then the last one is to do two things at once, which is to say that I'm going to multiply both sides by this and both sides by this. And that will give me straight to doing what you guys, some of you told me at the start of the topic, but you couldn't really explain to me why it worked. That's what we call cross multiplying. And from there, we'll just expand out as before. Okay, I hope that helped. Make sure that you also look at the transum links that I've posted when I've put up the links to my videos, because there's some really good practice in there for more equations. Remember, whenever you're working with a video or an on-screen resource, make sure that you've got your pen and your book out so that you're getting really confident with how to go from one step to the next. Thanks for watching. Let me know if you've got any questions.